Hello everyone, I hope you're doing well and I hope that you're ready for another lesson in geometry. We are in section 4-5 today and we are talking all about isosceles and equilateral triangles. You've likely heard of a number of these definitions that I'm going to be talking about today, but we're going to expand it a little bit more and talk about a couple theorems and some more ways that we can set things congruent to each other. But first, let's, just do a quick review about how we can identify and classify triangles based off of their angle measures and side lengths. So we're going to start with classifying triangles by their angle measures. Here I have something called an acute triangle, and the requirement for a triangle to be considered acute is all three angles are acute. Next, I have something called an equiangular triangle. So notice it sounds like equal angles, and that's exactly what it means. It is a triangle where all angles are congruent. So this guy is 60, this guy is 60, and this guy is 60. I also have something called a right triangle, and a right triangle has one 90-degree angle. And finally, we have an obtuse triangle, and it has one obtuse angle. Like I said, you've likely heard of these definitions before. Hopefully you have, but that was just a quick refresher. Let's classify some angles based off of these words now. So it says classify triangle FHG. I'm going to use highlighters to kind of help us see what we're doing here. So I have triangle FHG, and that's right here. In triangle FHG, I have two angles that are 60 degrees, and then I have this guy up here. Now this 90-degree angle is representing this whole thing, not just this small section. So I might have to calculate what that small section is. So what must this be in order for the three angles to add up to 180? It's going to be 60 degrees, which means that this first angle, or first triangle, I should say, is an equiangular triangle. Let's look at triangle FHE next. Okay, so triangle FHE is right here. Here I have two angles at 30 degrees. And what must this angle be? Well, this angle is going to be 120 because once again, I need all three angles to add up to 180. Well, and since I have one angle that is larger than 90 degrees, this is an obtuse triangle. Finally, I'm going to classify triangle EHG, which is the whole thing. I can trace that for you as well, just so you can see it. That is the whole thing. And something that's important to notice is this angle right up here. Triangle EHG has a 90-degree angle in it, which means it is going to be a right triangle. Now, this is only used if we're classifying something based off of its angle measures. We can also classify triangles based off of their side lengths. So here we have something called an equilateral triangle, where all the sides are congruent. We also have something called isosceles. Isosceles is going to be a very popular term that we use in this class based off of just different properties isosceles triangles have. But isosceles triangles have two sides that are congruent. And finally, we have a scalene triangle. A scalene triangle has 3 different side lengths. So it might look like that just to kind of show you a little bit better that they really are all 3 different lengths. So I'm going to say for scalene, all 3 sides are different lengths. Equilateral, all sides congruent. Isosceles, 2 sides congruent. Scalene, all sides different. So now we're going to classify some more triangles based off of their side lengths this time. So first we're going to classify triangle EHF. And I gotta find it. Here we go. EHF is right here. Now, be mindful of what we have marked here. We have a line right here and a line right here, indicating that these 2 sides are congruent to each other. So that means that this has 2 congruent sides, therefore it is isosceles. Then we want to do triangle EHG. Triangle EHG is the whole thing. So from E to H to G. I have one side length that's 12, one side length that's 11, and then the other that is 14. So I have 12, 11, and 14 for my side lengths. That kind of looks like a date, but it's not. So that means since they are all 3 different, this is going to be scalene. Finally, I want to classify triangle GFH. Here, I have a side length that's 4, a side length that is 11, and a side length that is 10. I'm getting that 10 because these 2 are congruent. Once again, all of those are different lengths. So this one is also scalene. Hopefully this first part was review for you. You've heard of those before. Flip that paper over and we have a lot of theorems to talk about real fast. I'll just kind of go over them in general. The first 2 are closely related. They are converses of each other. And it says if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. So I have a congruent side and a congruent side, which means this angle is congruent to this angle. It's going from the side to the angle. The converse of that is saying, oh, hey, I have the angles. Let me then conclude that the opposite sides must be congruent. So this is used for isosceles triangles. Notice right here the word isosceles. The Isosceles Triangle Theorem is telling us that 2 of the angles in every isosceles triangle will end up being congruent to each other. We also have some corollaries to these, and it says if a triangle is equilateral, then the triangle is equiangular. And then that can also be put in reverse as well. So I'm going to say the summary of these guys all equiangular triangles are also equilateral and vice versa. So there's a summary of the second half of these 2 things. Let's put that into action with a couple examples so you can see what this actually looks like. So flip your page, and we have just 4 examples with this, and then we'll be done with the notes. So it says, solve for the missing variables in each image. We are given information in each, and it looks like we're working with isosceles triangles in each one. So we are going to solve for anything that is unknown or any variables in each of these. For the first one, I have 2 sides that are congruent. So I'm going to mark those a little bit darker for you guys. Now, if these 2 sides are congruent, that means the angles opposite of them are congruent. So this guy has to be congruent to this guy. So now, if I know that these 2 are congruent, then y must automatically be 52 degrees. So I'm going to say y is equal to 52 degrees. That's one unknown that I needed to figure out. Now I need to figure out how I can calculate x. Well, don't forget that the rules of the triangle have not changed, so the angles still need to add up to 180. So I can say 52 plus 52 plus 14x plus 6 is equal to 180. I'm just going to add up all the angles and set them equal to 180. So 52 plus 52 plus 14x plus 6 is equal to 180. Now I'm going to start simplifying. So 52 plus 52 plus 6 is going to equal 110. I'm just combining like terms there. Then I'm going to subtract 110 from both sides because I have to do the same thing to both sides of the equation. And that gets me 14x is equal to 70. To finish this off, I'm going to divide by 14 on both sides, and I get x is equal to 5. So now I have found all of my missing variables in the first problem. Let's go on to the second one. Here, once again, I have 2 congruent sides and 2 congruent angles. I don't need to figure out anything about the angles because there are no unknowns there. But I do need to figure out what x is equal to. Notice that these are labeled on sides that are congruent to each other. So as a reminder, I'll write it up here for you. Set congruent parts equal to each other. If 2 parts of a triangle are congruent, then you should set them equal to each other. So my equation is going to be 2x minus 9 is equal to x plus 5. Then I'm just going to start solving for x. So subtract x from both sides. I get x minus 9 is equal to 5. Add 9 to both sides, and I get x is equal to 14. Let's keep trekking along. Do not let orientation throw you off. Here, I have 2 sides that are congruent to each other. That means the angles opposite of those sides are also congruent to each other. So this angle is congruent to this angle. All I'm trying to do is solve for y because that's the only variable in this problem. But how am I going to do that? This is not congruent to 65. 65 is congruent to these guys, so I know 65 is down here. But how can I figure this one out? I'm going to use that common rule that we've been using over and over, that the angles inside a triangle add to 180 degrees. So I'm going to say 65 plus 65 plus 3y plus 2 is equal to 180, because all 3 angles in every triangle add to 180. Now let's start simplifying. I have 132 plus 3y is equal to 180. Subtract 132 from both sides, and I get 3y is equal to 48. Then I'm going to divide by 3, and I get y is equal to 16. And I'm done with that problem. Here I have one last example. Once again, I have two angles that are congruent to each other. This is marked. However, I do not have that these angles are, or these sides are congruent to each other. But remember, whoops, wrong piece of paper. Remember, from this right here, it said, if two angles of a triangle are congruent, then the sides opposite those triangles are congruent. So that means that we can conclude, oh, hey, if these guys are congruent, then this must be congruent to this. And now I can move on with that. So we need to know why we're setting two things equal to each other and not just do it blindly. So because these two sides are congruent, I know this is an isosceles triangle, and I now know that 2x plus 6 is equal to 3x minus 6. Then you just start using your algebra skills to solve for x. So I'm going to add 6 to both sides. I get 2x plus 12 is equal to 3x. I'm going to subtract 2x from both sides, and then I get 12 is equal to x. And I'm done. Hopefully this is making sense for you. It's all about isosceles and equilateral triangles. That's really the big thing from today. So if you have questions or need extra help, be sure to bring that to me in class tomorrow. And until then, have a good night.